When we try to solve a problem, we need to approach it in two ways. First, we need to approach it top-down. We need to understand the basic characteristics of the problem. What is the program required to do? What are the big steps that we need to take? What are the major tasks that we need to accomplish? If we were not to write a program, how would we solve the same problem if we didn't have a computer? After we have gained the main understanding of the problem, then we also need to start working bottom-up, start building the small steps that will actually make the complete solution, and also test them. So what little problems can we break the problem, the bigger problem, so that we solve and test them? What kind of Java classes will we need? What kind of objects do we want to have that will be interacting with one another? And this will also lead us to what kind of methods we would like to have those objects invoke. How are we going exactly to write the classes? Several times when we are working on a big project, when we need to write lots of software, we need to work as a team. There will be several software engineers involved into this project. So one of the major challenges is to break the bigger task into small independent tasks that every programmer can tackle, can attack. In Java, the way that we do that is by dividing on class boundaries. So for example, Alice may write the class host image, while Bob will be writing the class steganography. Alice will not have to worry about how Bob will exactly read and write the images, while at the same time Bob will not have to worry about how Alice will do the image manipulation. Java supports the teamwork by the concept of encapsulation. It is a form of information hiding. The programmers that are not writing a particular class only know the information that they really need to know about that particular class. And encapsulation serves two purposes. On one side, it hides the implementation details from other programmers, so that if the programmer that is writing a class makes changes in the implementation of the class, the other programmers don't have to be affected. They don't have to know about them. At the same time, it is preventing other programmers from modifying certain methods or fields from the class in ways that they shouldn't. So it is a kind of safety net for the code. The way that encapsulation is made possible is by using certain modifiers, inserting particular words, reserved words, in front of fields and methods, which are actually there to say how exactly other classes, members from other classes, can access or not access these particular fields or methods. And these are the words that you need to know and we will be using a lot. You have already seen the keyword public, for example, public static void main. The keyword public gives the most access to a field or method. So any other method can access this particular variable or a particular method from any other class. When a method or field is declared as protected, it is only the methods in the same class or subclasses. Subclasses is a term that we have not discussed yet, and we will discuss extensively when we talk about inheritance. Or in classes in the same package can access. So the protected keyword is a keyword that we will see a lot after we discuss inheritance, and we will get back to the Java access modifiers and we'll revise this table. When we put no modifier in front of a field or a method, then that is as if we declare it, as we call it, package private. It is only the methods in the class or in classes in the same package that can access that particular field or method. Finally, the most restrictive modifier is the private modifier. If that is in front of a field or a method, it means that only methods in that class can access that particular field. No other classes can see that field. How then should we be using these access modifiers? Which one should we be using under what circumstances? The conventional wisdom is that we should make the methods public, allow anyone to use them, and having that in mind, we should write the method bodies, as we say, defensively, so that we protect the internal states of objects. At the same time, the way to protect the state of objects is by making the fields private. Only the methods of our own class should be able to modify them. For constants, which are final fields, it doesn't really matter whether we're going to declare them public or private, because the fact that they are final means their value cannot be changed. So we can declare them as public without any effect to privacy. The conventional wisdom, again, is that we make the fields private. However, that means that no other classes can see those fields. If we do wish to provide some access to members of other classes, then we need to write specific methods that will allow other classes to access these fields. There is no special Java syntax, but there is a naming convention. We can write a method getX, for example, when we have a field named X, and we can write a method setX when, again, we have a field named X in the class. Those methods are called accessors, getX, or mutators, the setX, and they can either provide the value of the field or they can change the value of the field in an object. These methods will do this work exactly. As the name implies, the accessor methods allow only read-only access. We just provide the value of the variable, while the mutator methods allow controlled change. So it is still different than having the fields public, because inside the mutator method we could control how exactly changes are allowed. For example, we could say that the value of a particular integer variable should only be allowed to change within a particular range. This is something that we wouldn't be able to enforce if we made the variable public. At the same time, when we're writing the accessor method, so that we make sure that it is a read-only access, we need to be particularly careful when we are providing an accessor to a reference variable. We will come back to this topic in later videos.